Hey, what's up, guys? So just rejoining you where I left off on Friday was when I recorded and posted that video. We're gonna pick back up in the notes and hopefully fill in some gaps. So, if I didn't clearly mention it Friday, a mole has two definitions. Okay, so it means a dozen of things. Nope, it means 6.02 times 10 to the 23rd of things, just like a dozen does. A dozen means 12. Mole means 6.02 times 10 to the 23rd. That's all I'm trying to get you to do, is just relate it to the term dozen. So, if you can please do that, that'd be great. Oh, and I forgot my lower third there. So if you can please just get used to that understanding, that note, great. Oh boy, that's not what I want my back to be. That's disgusting. Eek. Transparent, please. No, I see what happened. Okay, I don't want any virtual replacing there. I want my background changed. Sorry, guys. So, anyway, mole is like dozen. It's just a mole instead of a dozen. And it can be used the exact same way. Anything, there can be a dozen of anything. There can be a mole of anything. Mole is 12 grams of carbon also, though. Wait a minute. One atom of carbon weighs 12.0 atomic mass units. That's what it says on the periodic table. When I look at it, it says that carbon is 12.0 atomic mass. It is both of those things. We're repurposing it in this unit to also mean the molar mass. It turns out someone did some studies in math and found out that a mathematically equivalent number of 6.02, 1 mole of them, 6.02 times 10 to the 23rd of carbon, that's its molar mass. The molar mass is the same as the atomic mass, just in grams instead of atomic mass units. Who knew? They figured it out for all the elements. If I have 1 mole of any element, it weighs the same. It's kind of like saying if I had a dozen donuts and a dozen hamburgers, they would weigh the same, as a periodic table of food would present them. They weigh the same as the periodic table of food would say one atom of them. Like it's shocking that entire one number calibrates to all of the atomic mass units just in grams. It's very cool. We end up using it for various sorts of conversions because it gives us two conversion factors. Avogadro's number is that. Probably read some of those different equivalences. The mass portion is called the molar mass. So I would have you repeat that. Say molar mass. Molar mass. Cool. So, next up. We use molar mass to calculate, or we can calculate molar mass of various substances. Don't remember if I went through here. Calcium is, we can find its atomic mass is 40.1 AMU. Its molar mass is grams per mole. The biggest difference there is that grams per mole setup. Chlorine, hydrogen, and you see what's going on here. We use that in our periodic table. Now, what would happen if I had a compound? Well, I just use the subscripts to tell me how much of that compound, how many atoms of that compound, and I just count all the atoms' atomic masses and add them up together to get the compound's molar mass. What? Shocking. So we're calling that atomic mass also the molar mass. A little quick check question. What's the molar mass of CuCl2? Copper, 63.5. Chlorine, 35.5 grams per mole. There are 2 chlorines because the subscript 2 says 2 chlorines. Times 2, 71. 71 and 63.5 is 134.5 total grams per mole. Now, that's how you do it. You probably could go practice that right now and be just fine. Molar mass practice number 2 worksheet would have you do a little bit of that practice, as well as a little bit on molar mass, or the practice with moles, molecules, and mass moles and molecules. Nevertheless, this is a great practice. Oh, the other thing was the way I'm showing you how to add these up, where I just kind of stack them up and then show you the addition below, is a great method that we're going to use when we get into percent composition as well. So, just worth trying it out. But don't get messed up with polyatomics. That just means we got to use we just have to use some distribution going on. Calcium, there are 40.1 each, 3 of them. 2 phosphoruses, 31 each. Oxygen, 16 each, there's 4 of them. Well, times 2 is 8. Add them up, 310.3. Once again, if you're writing this, the bare minimum would be to write down these total additional masses and the total molar mass, so that way it'll help, you can leverage that later on, that format, for solving other problems as we go forward. Quick check question, pause right now, try to find it on your own, and then come back to the problem, come back to the video, and see if you got it right. Pause if you didn't already. Okay, I'm assuming you've paused already. And then you find the masses for each. 2 aluminums, 3 carbons, and 9 oxygens. Add them up, 234 grams per mole. Did you get it? Let me know if you have any questions. So other ones we convert, you use that worksheet, molar mass practice number 2. That's really going to get you there. Molar mass practice number 2, molar mass practice, or excuse me, you can calculate all the molar masses on molar mass practice number 2 and molar mass number 3. If there's a line that says molar mass equals, you can do that for all of those worksheets, for all of those. Let me just show it to you because let me refer to it. There it is. Let me get me back over here. So there's molar mass practice number 2, and there's the line for molar mass, and all the problems have it. Front and back, page 1 and 2, and then also molar mass practice number 3. So you can go ahead and do that right now just to practice doing the molar masses and being very careful. If you feel good about that, then just keep on going, and let's get back to the rest of the video and do some more introduction to molar mass calculations. Okay, remember Avogadro's number. Think about what it means. It means particles, molecules, and numbers in some cases. And then we would do some practice. Now this practice will lead directly into worksheet 1. So we just told you how to start off worksheet 1, or molar mass practice number 2 and 3. Worksheet 1, let me go back to this video, this other one. This is practice with moles, molecules, and mass. These slides will kind of get you started on the conversions, so you can do the rest of molar mass practice number 2 and the rest of molar mass practice number 3, which you've already done. You could already have the skills to calculate the molar mass for number 2 and number 3, but the conversion aspects of it, this right here is a great introductory piece to it. So I want you to do that one first, and that's the first worksheet I check for the in-class students also. So if you have 1.8 moles of Na2SO4, how many molecules do you have? Well, remember Avogadro's number. Oops, sorry. If we remember Avogadro's number, which we do, then we would say I have, the first part says 1.8 moles. Oops, nope, sorry. First part says I have man, that's awful. 1.8 moles. Now normally I would ask you to write out Na2SO4, but it's going to take me a long time, so of this, and then I need to do a T-chart conversion. Sorry, my lines aren't straight. I'm using a mouse to do this, so this is a little more difficult than normal. How many molecules? I want to go to molecules. And then I want to get rid of moles, so I'm going to put moles down here. And 1 mole equals the conversion factor, 6.002 times 10 to the 23rd. This is one type of conversion, going from moles to molecules. From moles to molecules. You make that conversion, you multiply across the top, divide by the bottom, fill out your T-chart similarly over and over again, and you'll get those problems. The rest of worksheet 1 shows you how to do, sets you up with some other problems as well. Sets you up with some conversions of molar mass. Let me get back to it. sets you up with conversions of molar mass and moles and the particles. So that's what we first looked at. And then has you can do some balancing equations and then more of these conversions with the molecules. Notice the example in each of these parts. Follow that example as your lead in doing the rest. Send me a picture of your work. That's going to be the best thing you want to do, and I can guide you from there because it's probably just one little minor mistake. You may have multiplied when you should have divided, or divided when you should have multiplied, something like that. In this case, we multiply because we have it top times top. If we have molecules over here, converting to moles over here, I would divide in that case. So just try it out. Get used to using your calculator. I'm about to show you a little crash course on using that in the calculator. The E button has EE. It's normally the second button above the number 7, comma or times 10 to the negative 1. So take a look.